For today, we are going to go through calculus. Let's take another example involving fractions, where we want to differentiate using the first principle, otherwise known as definition. So for this, the same approach will apply. I will still suggest that you first of all differentiate this using the general formula. Take the exponent of this, that gives us 5x to the power of -1, and then differentiate using the general method. So if we take this, it's -1 times 5, which will give us -5, and then we have -1, -1, -2. So this will be the first derivative of this function using the general method, which if we write as positive exponent becomes -5 over x to the power of 2. So what we're going to do is we're going to keep this by the side as a check to whatever our answer is going to be while we apply using the definition. Remember, if you are asked to use the first principle and you cannot use the general method, else you lose the marks. So let's go. If first derivative of this function using the first principle, it says that the limit of the function as x tends to h, as h tends to 0, is the limit of f of x plus h minus f of x divided by h. So what we don't have here is our f of x plus h. So we go to that and get our f of x plus h by replacing our x with x plus h. Now let's sum it into the function to get the first derivative. Remember, like I said previously, our notation status. So our f of x plus h in this case is f of over x plus h minus 5 over x, which is our f of x. Now what we need to apply here is resolving fractions. So let's make this a single fraction and then take it from there. So this is 5 over x plus h minus 5 over x. If we take LCD, LCD will be x into x plus h. So this into this will give us, so if we go on, the limit of this function as h tends to 0 will be, we have this into this, will into the LCD, we have x, and then this will give us 5x minus x into this will give us x plus h. So we have 5 into x plus h, and our denominator is x squared plus xh divided by this denominator as, and that is the limit of that function as h tends to 0. So let's simplify. This will give us 5x minus 5x minus 5h all over x squared plus xh times 1 over h. Let's complete this here. Now, remember, notation goes on. It is the limit of the function as h tends to 0. Now, if we have this, 5x minus 5x takes care of each other, and then we'll have minus 5h. Minus 5h, h will cancel out h here. So we have, what we have is the limit of that function as h tends to 0 of minus 5 left in the numerator over the denominator, which is x squared plus xh. Now, if we want to get the first derivative, we now sub 0 into for h. So this will give us x squared plus x times 0. So our final answer will be 5 over x squared, which is the first derivative of this function using the first principle method of by definition, which if you check and compare this with what we got previously, you will see that they are the same. Remember, this is just done as a check, and then you can continue working on your definition. And after, you must compare what you have here with what you have there to be sure that you have not messed up the sign anywhere. So this is the method we use to resolve differentiation by first principle when fractions are involved. Remember, the knowledge of LCD is very important. So please, if you need more clarity or if you have any particular question that you want us to go through, please pop them in. Meanwhile, keep on studying, keep on sharing my video, and keep on encouraging your friends to subscribe. I'll see you in the next video.